Hello everybody, my name is Mr. McAllen, and what we're going to work on today is how to work through some complicated tangency problems. What we're going to first look at is finding an equation for a line that is tangent to the graph of y equals e to the 5x. And it passes through, the tangent line passes through the origin. So I'm just going to draw a quick graphical representation of this, just to get an idea of what's happening. Here's e to the 5x, and I have a point of tangency for a line that goes through the origin. So right at this point of tangency, the thing that we have to remember is that the x value, the y value, and the slope are all the same value for that point of tangency. We're going to use this to our advantage in solving the problem. We start out with, as they asked, for finding the equation of that tangent line. This equation will be y equals mx. Now I'm leaving out the value b because it passes through the origin, making the y-intercept 0. So we start out with our equation y equals mx, and we plug in, because at the point of tangency, the curve has the y equation e to the 5x. So I'm just going to replace y with e to the 5x. I'm going to figure out the slope of the curve and multiply that by x. And this is what will help me figure out what the x value is where everything is equal. Using calculus, m is equal to the derivative of e to the 5x. When I calculate the derivative using the chain rule, I'll get 5e to the 5x, and that's what I'll replace with that value of m. E to the 5x, as I wrote before, equals 5e to the 5x times x, and now I'll solve for my x value. That will tell me where the point of tangency is, and by the nature of this problem, I have e to the 5x, I'm dividing it by e to the 5x. As long as my denominator is not 0, this should work, and since it's an exponential equation, I know it will never equal 0. So I have x is equal to 1/5. So that's the coordinate where the point of tangency exists. Knowing that, I can now figure out my slope at x equals 1/5. And I'll use that slope to find my equation of tangency. So the slope at x equals 1/5 is equal to, again I'm just using this equation, 5e to the 5, plug in my x value, 1/5. So my slope is going to be 5e to the first power. This is the value of slope that I need to plug in to the original equation, y equals mx, because the purpose of the problem was to find the equation of tangency. So I'm just going to plug in y equals that slope value, 5e, and multiply that by x, and this is my equation of my tangent line. I'll just write it here so that we know our equation is y equals 5e, which is a constant, at this point, times x. Let's try to do another problem. Let's consider an equation of a tangent line to the curve y equals x squared plus 3 that passes through the point, let's say 0, 1. Let's see if we can figure out the equation of a tangent line for that. Again, same exact idea. We have now a parabola, and we have a point of tangency. Not a point of tangency, but the coordinate 0, 1. We'll have a line. I'll just draw a representation of what could be happening. We'll have a line that is tangent to the curve at an x and a y value that shares the same slope as the tangent line and the curve's point of tangency. If you look at this closely, the difference between this equation and the last one was the last one we had a nice simplification where y equal just mx because we did not have a y-intercept. It went through the origin. But this time we're going to handle a little bit of a different situation. This time our equation will be y equals mx plus b. And we know what our b value is. Y equals mx plus 1 because our y-intercept is at y equals 1. So I'll set up the same way we did before. Y equals mx plus 1 because we know that the y values are identical for the curve and the tangent line at the point. I'm just going to put in x squared plus 3 equals, don't know my slope value yet, times x plus 1. I'm going to find my slope value because the slope is equal to the derivative of the curve x squared plus 1. So the slope is going to be just 2x. I'm going to plug that into the equation. I'm going to now simplify my equation. And I get, when I solve for x squared, I have x squared is equal to 2. And I get x is equal to plus or minus root 2. I have two solutions. So what could this mean? When I go back and look at the curve that I just made up, I didn't realize this at the time, but in making the problem go through 0, 1, I have two possibilities. I have the possibility that it goes through this point, and I'll draw another tangent where it goes through that point. And I know my curve doesn't look symmetric, but my x values are at negative root 2 and positive root 2. This is interesting because I didn't expect to have two solutions, but we do. So, and I only said to come up with an equation of a tangent line. So I'll use the equation of the tangent line to the right, where I have y equals, I'll do it in blue so it corresponds, y equals mx plus 1, and my tangent line slope, the equation for tangency, for m, was, I'm going to evaluate that equation at x equals root 2, and that would make my slope 2 root 2. So my equation of tangency will be 2 root 2 times x plus 1. And there you have it. That will be my equation for tangency for the parabola, where that equation passes through the point 0, 1. I hope this video was of help, and I'm happy to say that it's a minute under 10 minutes, which is what I was shooting for. If you have any questions or comments, please comment to this video on YouTube, and if you like it, and if you want to see more videos, please subscribe. Have a good day.